we've had a little brief excursion into the long history of the philosophy of mind. We only glanced off it, it must be said. The topic is extremely rich. But we're going to shift courses now, and we're going to look at the history of the discipline of psychology, in as much as there is a discipline of psychology. As cognitive scientists, clearly we have scientific interests and they overlap with philosophical interests. Philosophy and science go hand in hand when it comes to unraveling the mysteries of consciousness and experience and understanding ourselves. To the extent that we are amenable to scientific inquiry, the scientific study of the mind, or all things mental, is what we call the discipline of psychology. But that word picks out very many kinds of human activities. Some of them adopt scientific instruments, scientific vocabulary. Some of them don't, wisely, because not everything is amenable to scientific treatment. For example, psychologists are often called upon to provide care after trauma, when people are troubled. The first thing we do is we call on psychologists to help people. Now that's what we might say soteriological. It's trying to help, and it's a perfectly good activity, but it's not necessarily rooted in science. There's the vast world of psychotherapies, which have little, most areas of which have little or no contact with scientific principles or methods. So when we speak of psychology, we must be aware that we're speaking of a broad array of activities. And if we speak of a scientific psychology, we're narrowing that down hugely. There's still a great variety of approaches in there, but psychology is much broader than that. And psychology is something, frankly, we're always going to do, whether we use scientific means or not. The term psychology goes back a long way. I think 1590 is the oldest I've found of it, but the concerns, that way of thinking, is much older than that, of course. But a science of psychology didn't come into being until the 19th century. That's only like 140 years ago. And there was significant developments in both Europe and in America, and they went in different directions, it must be said. In Europe, we're going to have laboratories, experiments and such, in the laboratory of Wilhelm Wundt in Leipzig, for example, the first experimental psychology laboratory. Across the water in America, there's going to be different ways in which the still vague notions of psychology are developed. And the principal figure there is going to be William James, marvelous character. His concerns are very different from Wilhelm Wundt, and he doesn't have a laboratory. And the reason that this emerges, this kind of questioning emerges in the late 19th century, is because science has really got its speed boots on. Modern science is not terribly old. It comes into being more or less in the 17th century. And then there's huge advances throughout the 17th, 18th, and 19th century. Let me remind you, it's only the middle of the 19th century that Charles Darwin introduces his theory of the evolution of species and makes it clear that humans are actually animals of some sort and need to be understood like that. This is a huge bombshell to the human imagination. There have been progress in fields like, physics has come a long, long way since Newton. And towards the end of the 19th century, we've got the electromagnetic theory, atomic theory, and we're going to have even more spectacular developments in the theories of relativity and quantum theory. So physics has come a long way. Biology has emerged as a science in this time. If we date the start of modern science to the 17th century and the shift to a heliocentric view of our position on Earth, that doesn't bring the whole of what we might call the hard sciences into being. They still need to develop. Chemistry has its own development. Biology has its own development. But by the late 19th century, they're fairly well established, and so people are simply thinking, this science stuff is great. How can we apply it to ourselves? Could we use this to study ourselves? This kind of questioning is much older than the term psychology. It always was soul science, to use a grotesquely outdated word here. We may shift to a modern vocabulary and use the language of minds. As we'll see in this module, the term mind is no better defined than the term soul. And most of the people who have contributed to the growth of our discipline were just as happy talking about souls as they were talking about minds. Descartes speaks of the soul. Immanuel Kant speaks of the soul. Mind talk starts overlapping with soul talk, and eventually, again, from the middle of the 19th century, science sort of separates itself from the constructions of the church's ideology. Appeal to God is no longer possible within science after the middle of the 19th century. Before that, it's obligatory. That's a huge shift. But the kind of questioning that gives rise to psychology has always been there because we want to understand others. Do you ever notice that other people are really peculiar and you might wonder what's going on with them? And we want to understand ourselves. Did you ever notice that you're pretty peculiar and you'd love to understand yourself? These are not original questions. As well as trying to understand others and understand ourselves, we also want to know why do people act like they do? Why do they do these damn stupid things or these wonderful things? And just as we can ask that question of others, we also want to ask it of ourselves. Why did I do that? Why do I do that? Why do I persist in doing that? How could I do things differently? These are psychological questions, and they're as old as the hills. And furthermore, along with these questions always comes the question of how to live a better life. This is soteriology, and it is entirely foreign to science. Soteriology means trying to save yourself, improve yourself, do better for yourself and for others. And you can see that this is a widespread concern, obviously. Any ethical system must be concerned with how we care for each other, for example. But it's not clear that all this comes together to form a natural science of any kind. As ideas progress, two big poles emerge in the scientific articulation of psychological concerns. And they don't quite meet. One term is experience, which you may associate also with consciousness or feeling or why things appear to you as they appear to you. Experience intrinsically private, hidden, secret. So that's a whole set of questions revolve around that, the first person perspective, first person feelings. And a whole other bunch of questions arise around behavior. Why do people do what they do? How do people do what they do? How do you change what people do? Experience and behavior become two strands within scientific psychology. And to this day, different approaches have very different interests in these twin poles of experience and behavior. Now, I mentioned that different developments happened on either side of the Atlantic. In Germany, Wilhelm Wundt was setting up his experimental laboratory, and we'll look at some of that experimental work now in a minute. But let's start over in America, where the most important figure was William James. This guy with a big, big beard. Came from a very gifted family. His brother, Henry James, was one of these modern novelists, very, very successful. And indicative of the time, that style of literature is very psychological. Modernist novels, people like Virginia Woolf and James Joyce, put you inside a character's head in a way that hadn't happened in literature prior to that. William James wrote the first textbook on psychology. It's called The Principles of Psychology. And he was interested in experience, in conscious experience. He even gave us a term that we use in everyday speak about consciousness, which is the stream of consciousness. In a famous passage, he says, consciousness does not appear to itself chopped up in bits, whatever that would mean. It flows. A river or stream are the metaphors by which it is most naturally described. In talking of it hereafter, let us call it the stream of thought, of consciousness, or of subjective life. So that situates William James's concerns fairly well. And he referred to the stream of consciousness as the ultimate fact for psychology. Notice it's not an articulated fact, it's not something that you can write down, but he says this is what psychology needs to be involved in. Now, the European developments will be chasing entirely different goals. The idea of the stream of consciousness didn't turn out to be as useful in scientific terms as William James would have liked. It was very, very influential in literature, including in the novels of his brother Henry James. But increasingly, the mysteries around consciousness and how we talk about experience haven't gone away. They're still very much with us. It's interesting to note that as well as writing the first textbook on psychology, his magnificent Principles of Psychology, a vast tome in which he considers huge amounts of different things, he wrote another very important book called The Varieties of Religious Experience. That might seem odd for a scientist to do, but what he was doing at the time, in a manner appropriate to late 19th century, was he was trying not to get involved in arguments about gods and angels and such like, but he was wondering what's it like to belong to believe as a Hindu or a Buddhist or a Muslim. So he was interested in the experiential aspects, and he was aware of cultural diversity. And this gets expressed here using the notion of world religions. That was of its time, perhaps. But he was informed by other approaches to experience, because in Buddhist philosophy and in Hindu philosophy, we will find that there are thousands of years of empirical, hard reasoning and debate and questioning about precisely the kind of question that William James is asking, that is about the nature of experience. The so-called contemplative traditions, those that you associate perhaps with practices of meditation, have long, well-documented histories of discourse here, where people like William James were just getting in on the act. And to this day, we're still learning how much more there is to learn from these traditions. Now, happily, William James was not a fundamentalist of any kind. He didn't insist that all scientific stories must resolve to one account of truth. He was what we might call a pragmatist. And in fact, we identify a school of American pragmatism with William James, John Dewey, and Charles Sanders Peirce as the three main founders. And the pragmatist idea is not to arrive at pure truth, but to see if thinking about things in one way rather than another might be of benefit to us. Does it help us if we think of consciousness as a stream, for example? Can we make hay out of that idea? Now, to some extent, you can take that too far, and then psychology gets watered down into, oh, here's 10 quick, easy life hacks to improve your memory or sleep or whatever. So it can get watered down. But as a cognitive scientist, when we find so many competing ways of developing stories about ourselves and our behavior, some kind of pragmatism is always going to be needed, because no one school has got the whole story. So that sort of describes what was going on over in America. But there was a lot of activity in Europe too, and there was a lot of ways. If you don't have a science of psychology, it's not clear how you begin doing a science of psychology, given the differing motivations, looking into experience, looking into behavior. So one thing people did was they argued about it, like philosophers, using reason. And you can get so far doing that, and people will always do that. A discipline arose now primarily in the European sphere here called psychophysics. We'll have a look at psychophysics to try to understand it, and we'll look at how puzzling a discipline it is. Interestingly, it's about the only one of these early methods or approaches that persists to this day. Experiments without a good theory mean nothing. People have always done experiments. We're very creative in our experiments. It's very easy to ask people to do things one way or another way, but experiments don't deliver truth unless you have some kind of theoretical framework to understand, to make sense of what you're observing. So early experimentation looks a bit wild to us. There was a fad for experimenting with hypnosis, for example, something that we still don't have a good conceptual grasp of. So experimentation goes on, but you also need theory to help that. And there was a method that was applied in Germany, particularly in Wilhelm Wundt's lab. But it's kind of used by everybody, which is if you want to find out about the mind, hey, you know who has a mind? You have. Why don't I just ask you about it? Introspection means looking within, but it's unclear where the within is. But supposing you had an interior secret cavern called the mind, and you knew what was in there, I could ask you, what's in there? How's that mind thing going for you? That didn't work out terribly well. We'll come back to the problems of introspection later. But for now, let's look at the place where scientific method and psychological paradoxes and questions first come together. And this is the business of psychophysics. Isn't it a great name? Psychophysics, like psycho killer. In psychophysics, what we do is we recognize that physically we can measure some things. We're pretty good at physics. And in physics, we have instruments and tools, and we measure and we get good quantitative observations of things. The psycho bit is the unobservable mind bit, that puzzling bit. We can't measure that. We have no instrument for measuring that. But we can ask people questions. That's a weird scientific tool, but we're going to use it now. We're going to ask questions. So we're going to take something that we know how to measure, change its value, and ask people questions. What changed for you? Now we can do this, for example, in the domain of vision, but we're going to illustrate it here in the domain of sound. Sound has a physical aspect to it. It consists of vibration in the air. Something happens here, and that causes air vibration, which causes movement on the eardrum. Lord knows what happens after that. It's a big mystery. But we can measure those vibrations in the air, and we can measure how fast the air is vibrating. That's a physical measurement. The unit is hertz, and it's the number of times per second that the air vibrates. So if the air vibrates 100 times per second, this is what it sounds like. Kind of ugly. So that's 100 vibrations per second. Then we can ask someone, okay, did you hear that? Now I'm going to play something that's 200 cycles per second, and you tell me whether it's higher, lower, bigger, redder, wetter. How does it change? So here's 200 hertz. Right. We've got the physical side of things. We know we played a tone of 100 hertz, and now we know that we played a tone of 200 hertz. And we ask someone, what changed for you? And you say, well, it was a higher pitch. Ah, pitch is not something we can measure. Pitch is something you report. That seems higher or lower to me. So here's a subjective side of things, pitch, and here's an objective side of things, cycles per second, hertz, frequency. And we can ask, is there a meaningful relationship? Well, we just noticed that a change of 100 hertz led to a change in pitch. If there's any musicians among you, you may have noticed it was actually an octave higher, like going up, whoa, one scale on the piano. So let's see if we play another 100, we add another 100 hertz, does it go up another octave? That's 300 hertz, and the non-musicians are getting left behind at this stage, but the answer is no. That's not another octave. The shift from 100 to 200 has a counterpart not in the shift from 200 to 300, but from 200 to 400. Here's 400. And that sounds like the 100 and the 200. So we get an apparent even distance in pitch, an octave, for every doubling in frequency. So we can check that. Let's double 400 to 800. And double it again. Right. Each time we doubled the frequency, the pitch seemed to move by an equal sort of amount, an octave on the piano. And so we can look at the relationship and see is that lawful between it, and we can plot what we can measure, which is frequency in hertz, and what we report, which is pitch as perceived. And the only way to find out what someone perceives is to ask them. Now there's lots of refinements of this method. I just played you a series of tones and spoke informally about it, but we can get really busy with this and see what's the smallest possible difference that you can perceive, for example. That's called a just noticeable difference. Or we can find how much change do you have to make to this in order to make it sound or seem like this. There's all kinds of comparative things, but what they all have in common is we have a secure grasp of the physics and an absolute conundrum on the side of the mind. All we're doing is asking people. So we've got that's the psychophysics thing. On the one hand, we've got a measured physical property. On the other, we've got a perceived property. We just did that with frequency and pitch. Staying in the domain of sound, we could have done it with amplitude. That's the amount of energy that's in the air. And loudness, which is something that people perceive. We cannot measure loudness, but we can ask you, is this as loud as that? Is this twice as loud as that? And if we change from looking at the vibration of the air to looking at the properties of light, which we also have a good physical handle on, we can measure something called luminosity, which has to do with the number of photons going around. And we can ask people about brightness, which is a perceived property. Notice we cannot measure brightness. It's a psychological construct. We can only ask people about it, but we can measure luminosity. And we can do this in arbitrarily complex domains. For example, we could do it in the domain of fine French wines. We can take a fine French wine, or a bunch of them, and we can measure their chemical composition, get a physical grasp, a hard scientific grasp on what's in there. And we can ask people, what's the nose on this? What does this make you think of? Now, in wine tasting, we won't end up with a secure relationship between the chemical composition and the words people use, for reasons. We get a very good grasp, though, when we look at frequency and pitch, or luminosity and brightness. We can do this in the domain of touch. We can ask, how much pressure am I exerting on you now? We can measure physical pressure, that's force, but we can also ask about perceived pressure. So here's a game that opens up that seems to offer a scientific route in, that is, it uses good physical science, but the psycho bit is still a bit odd. Now, it's a remarkable thing that pretty much every single concept employed in scientific and proto-scientific psychology has changed and changes rapidly. The constructs of psychology are not safe. But remarkably, psychophysics was introduced at the end of the 19th century, and it is still with us. It still sticks around. It's founded on a weird dualist paradox that insists that what we can measure can be related to something that you can report on and I can ask you questions about it. That's quite unlike any other scientific endeavor. It makes it very obscure what exactly is being measured. Asking people questions is not normally the way that we approach, for example, chemicals or planets. So it's a very, very weird one, and yet because of the rigor on the physical end of things, it remains a very popular domain. And it's a good example of some of the paradoxes we meet as we begin to uncover what a science of psychology began to be.